My lectures will in general not be a repeat of your book, but they will be complementary to the book. The book will support my lectures, and my lectures will support the book. You will not see any tedious derivations in my lectures. For that we have the book. But I will stress the concepts, and I will make you see beyond the equations, beyond the concepts. I will show you, whether you like it or not, that physics is beautiful. And you may even start to like it. I suggest you do not slip up, not even one day. 802 is not easy. We have new concepts every week, and before you know, you may be too far behind. Electricity and magnetism is all around us. We have electric lights, electric clocks, we have microphones, calculators, television, VCRs, radio, computers. Light itself is an electromagnetic phenomenon, as radio waves are. The colors of the rainbow in the blue sky are there because of electricity, and I will teach you about that in this course. Cars, planes, trains can only run because of electricity. Horses need electricity because muscle contractions require electricity. Your nerve system is driven by electricity. Atoms, molecules, all chemical reactions exist because of electricity. You could not see without electricity. Your heart would not beat without electricity. And you could not even think without electricity, though I realize that even with electricity, some of you may have a problem with that. The modern picture of an atom is a nucleus, which is very small compared to the size of the atom. The nucleus has protons, which are positively charged, and it has neutrons, which have no charge. The mass of the proton is approximately the same as the mass of the neutron, is about 6.7 times 10 to the minus 27 kilograms. .7. The positive charge is here with the nucleon, with the neutrons, and then we have electrons in a cloud around it. And if the atom is neutral, the number of electrons and the number of protons is the same. If you take one electron off, you get a positive ion. If you add an electron, then you get a negative ion. The charge of the electron is the same as the charge of the proton. That's why the number is the same for neutral atoms. The mass of the electron is about 1,830 times smaller than the mass of the proton, is therefore negligibly small in most cases. All the mass of an atom is in the nucleus. If I take 6 billion atoms lined up, touching each other, I take 6 billion because that's about the number of people on Earth, then you would only have a length of 60 centimeters. Gives you an idea of how small the atoms are. The nucleus has a size of about 10 to the minus 12 centimeters, and the atom itself is about 10,000 times larger, the cloud of electrons, which is about 10 to the minus 8 centimeters. And if you line 6 billion of those up, you only get this much. Already in 600 BC, it was known that if you rub amber, that it can attract pieces of dry leaves. And the Greek word for amber is electron. So that's where electricity got its name from. In the 16th century, there were more substances known to do this. For instance, glass and sulfur. And it was also known and written that when people were bored at parties, that the women would rub their amber jewelry and would touch frogs, which then would start jumping of desperation, which people considered to be fun, not understanding what actually was happening to the amber nor what was happening to the frogs. In the 18th century, it was discovered that there are two types of electricity. One if you rub glass, and another if you rub rubber or amber for that matter. Let's call one A and the other B. It was known that A repels A and B repels B, but A attracts B. And it was Benjamin Franklin, without any knowledge of electrons and protons, who introduced the idea that all substances are penetrated with what he called electric fluid, electric fire. And he stated, if you get too much of the fire, then you're positively charged, and if you have a deficiency of that fire, then you're negatively charged. He introduced the sign convention, and he decided that if you rub glass, that is an excess of fire, and he called that, therefore, positive. You will see later in this course why this choice, he had 50% chance, is extremely unfortunate, but we have to live with it. So if you take this fluid, according to Benjamin Franklin, and bring it from one substance to the other, then the one that gets an excess becomes positively charged, but automatically, as a consequence of that, the one from which you take the fluid becomes negatively charged. And so that's the whole idea behind the conservation of charge. You cannot create charge. If you create plus, then you automatically create minus. Plus and plus repel each other, minus and minus repel each other, and plus and minus attract. And Benjamin Franklin, who did experiments, also noticed that the more fire you have, the stronger the forces. The closer these objects are to each other, the stronger the forces. And there are some substances that he noticed which conduct this fluid, which conduct this fire, and they are called conductors. If I have a glass rod, as I have here, and I rub it, then it gets this positive charge that we just discussed. So here is this rod, and I rub it with some silk, and it will get positively charged. What happens now to an object that I bring close to this rod? And I will start off with taking a conductor. And the reason why I choose a conductor is that conductors have a small fraction of their electrons which are not bound to atoms, but which can freely move around in the conductor. That's